Okay, today we're going to do lecture 11, which is the continuation of control structures from last week. And last week we looked at the concept of what a control structure was and tried to implement, in terms of some examples, how to change the flow or the control of the program statements as we're going through with JavaScript. And we're still on JavaScript, by the way. So here what we're going to see are some examples, and what you're looking at is an example of a while loop that uses a counter. So the arrow is pointing to the word while down here. Let's see if I can zoom in on this. Here it goes. Actually, zoom works. So we have while counter is smaller than or equal to 7. We're going to do some repetition. This is what's meant by a control structure. So the while loop will continue until the value of the counter is greater than what it's supposed to be, which is going to be while it's less than or equal to 7. So as soon as it turns into 8, we're going to exit the loop. And then we have something at the end here. It says plus plus counter. And some students usually wonder, why isn't it just counter plus plus? To evaluate counter and then increment it, or increment it then evaluate counter. So if the plus plus is before the word counter, you're incrementing it before you're evaluating it. So now we know what counter is. Counter is going to be, whatever it was previously. So it's just basically, are you going to increment it before you evaluate the content of it, or are you going to increment it after? Either way actually works, but normally you'll see it counter plus plus in a regular old counting situation where we're going to use the counter, then plus plus, use the counter plus plus. So here's an incrementing of the counter example. And that's how we're going to use the while loop to print out. And if you took this is actually fully complete code that you can cut and paste and put into a text file and run it. And if you do that, what you're going to get is something printing to the screen, and the print's going to be the font size. And the counter is being used in the font, actually. So we have font size is equal to, and this is kind of an interesting line of code, actually. We're using the document object model as before, and we're putting HTML text into the right command that's being sent to the right line. Right line is going to write it to the screen and put a line return at the end. So here we have a an opening tag bracket for P for paragraph, and the style is going to be equal to, well, we're changing the style of it to the font dash size colon, and then it's going to be the counter size. So the counter is going to start out with whatever the counter is initiated to, which is 1, and then go to 2, 3, 4, 5, 6, 7 as we go through, because there's only 7 levels anyway of the hierarchy of the font size. And then we're closing the bracket here. So this is all part of the style tag that is being put in here. And it's going to print out X HTML font size. And then this plus is actually concatenation, because we've also seen in JavaScript that when we don't specify the data type, it treats it as text. So when we use the plus, it's going to be a concatenation. So it's going to say counter, which is going to give us our counter value. So if we take a look at the code and what it does when we execute it, we get this here, where we start out with 1, 2, 3, 4, 5, 6, 7. You see how it's getting bigger, essentially, which is what our loop is doing for our particular program there. So, and it kind of shows you a couple different things. It shows you how to embed a style tag inside of a right line for a document, and it also tells you, a little bit about concatenation, and it also demonstrates the size of the font size feature. So it's a really nice, actually, kind of example. So that was the while loop, and now we have the for loop. For those people who don't program, you probably are not familiar with this. For people who do program in C or C++ or Java, you've seen a for loop before. But in unlike C++ or C, actually, unlike Java, usually you don't initialize the variable inside. So if we say variable counter, and then you'll see this a lot, actually, variable counter is equal to 1. And we know that we do variable counter or declaring a new variable. We're not using any counter that might be out there before, so the scope is within this. So we're guaranteed that counter is going to be equal to 1. We're not going to change counter anywhere else in the code. And we're reusing the name, which is kind of interesting because we can do that. And plus, this is also a different example, but up here we're just going to have our basic starting tags, our head section, our title, and then down here we just have a loop that's going on. So for variable counter is equal to 1, counter is less than or equal to 7, plus plus counter, increment the counter, and then we have our repetition condition. Same as before, actually. It's the same loop except for using it in a while, we're using it in a for, which is kind of interesting. So, and we can increment it right here. So with the for loop, it's what's called counter-controlled, and well, the while is also counter-controlled, but in the last example we looked at, but this one is specifically counter-controlled, and the counter is in the construct itself. So the for construct gives us the counter and the incrementing of the counter, where the while doesn't do that. While is just going to say while some condition. So if we're going to create a loop that never ends, use a while. Or if we don't know exactly how many times that loop is going to run, then we use a while. If we know exactly how many times, then we use a for or counter loop, because then we can count through 10 times and we don't have to increment. We can just go 1 through 10. But in this particular case, we're keeping a counter inside, or are we keeping a counter? No, we're using the counter out here. So we're letting the for loop organize our counter for us instead of putting the counter inside of the loop. You can do a for loop without a counter. You can check for a condition. While nobody's connected, do something. Or while program is still running, do something. It doesn't necessarily have to be a counter value that we're checking inside of the while loop. So just keep that in mind. And here's the program output again. It's the same as before. It's the same program. So you can accomplish the same task using two separate loops, using two separate techniques, but you're getting both the same results in both cases. So here's a little bit more information on the counter-controlled loop, where we have for, which is the key word that says this is a for loop, and then the control variable counter, and then the initial value we're setting it to. Not to be confused here, a lot of people try to put equals equals. It's not a comparison, it's an assignment, so equals 1. And then we're putting the semicolon here. And the semicolon looks like it's like being used as a delimiter to separate all these parts. It isn't actually. This is a complete statement with a semicolon, and then we have another complete statement with a semicolon. And we don't have a semicolon at the end. So most people when they're starting to learn the for, and this is the same thing for, this is the same syntax for C, C++, and Java as well. You have to remember there's no semicolon at the end because it's not ending. The loop goes, and then there's a, at the end of the loop is the end, and it comes back, and it doesn't end. It never ends actually because it's a loop. So there's no semicolon because that's not the end of the statement. So plus plus, so then go, okay, do everything inside, come back up to the top, plus plus, do everything inside. So it just runs for, in terms of continuously. So the loop continuation, condition, and then the increment for the control. So that's the typical structure of the header of the loop in terms of the for structure. And now we have kind of the logic in terms of establishing an initial value of a control variable. And up here we're saying the value is going to be equal, and the counter is going to be equal to 1. And then we're going to come into here and we're going to have this little diamond here as a check. In fact, this is a flow chart done a lot in software engineering to kind of demonstrate, especially if you're designing this loop or this process and you're trying to demonstrate to the programmers who are going to write the source code for this what we want the loop to do. Or if you're looking at some design documents, you'll see this a lot. So here we have the counter is less than or equal to 7. If it's true, then go this way. If it's false, go this way. If it's false, then we're ending. We're going to end this loop. So determine the final value of the control variable when it's been reached and come back out this way. Otherwise, and this is the same code as we looked at before, do this document right. So this is what's considered the body of the loop that might have multiple statements in it. And then we have the incrementer for the counter. And the incrementer for the counter is going to be basically going to be so counter plus plus or plus plus counter. And then go back around and do it again and do it again. So it's a flow chart of a typical repetition structure. Happens to be designed for either the for or the while. So a for loop and a while loop is pretty much doing the same thing. One's counter controlled and one isn't. So, and we have another example here, which is going to be a sum.html, which is the name of the file. In the old days, I used to have these actually on the website, and then I figured, students should just type them in. So if you type this stuff in, it's not too many lines of code. It's like maybe 10 lines here, 20 lines at the most for all of these examples. Another example of the for loop, but this one's a slightly different one. It's doing an increment here, number plus equals 2. So on the control loop for the for structure, it doesn't have to be a counter plus plus or a plus plus counter. It can be a counter plus 5 or something, or it can be something where we're incrementing it, but we don't necessarily have to do a single increment. So if here's a loop that will continue until the value of the number is greater than 100. because the number is smaller than or equal to 100. So we're looking for something greater than 100. The initialization is setting the number to 2. The repetition is setting it to, the condition is under 100. And then the number of the increment is doubling it. So why don't you just say 1 and go to 50? You're pretty much accomplishing the same task of going 2 then doubling it up to 100. But maybe the program output, it depends on some other type of incrementation or something. So what do we have here? So the sum here is going to be plus equal to the number. So the number is going to be the sum, and we're going to take it sum it up. So the sum of the even integers from 2 to 100 is, well, that's why we're only getting half of the information. We're getting the even integers. So we're getting 2, 4, 6, 8, all the way. We're only getting 50 numbers, but it's only half of them is not the odds. So this particular design is very suited towards its purpose. So you don't necessarily want to go for every particular loop, point being expressed here, starting with 0 and going to 10, because we have 10. It might be 2 to 50 or 2 to 20 if you want the odds and the evens, and then we're going through. We basically have to count up how many times we need to run this thing and then control it by our count instead of, in fact, this would be hard to do in a while loop because, well, actually not really. We'd have to increment it by 2. So we could do the same thing in a while loop. So it would work just fine. So the output says the sum of the integers from 2 to 10, the even integers, is 2,550. Everyone wanted to know that answer probably for some reason. Alright, so here we have, let me zoom out a little bit so I can see this example here. This one's called interest, and it's calculating up in interest. So in terms of what's going on, we're calculating the compound interest, and each one of the examples actually on the title says what it's doing. So you can, when you're cutting and pasting and using these examples, you can kind of get a feel for what I want to accomplish. And it's nice to be able to look at examples actually and copy, because a lot of people learn how to write control structures by copying what they see and then modifying it to make it work. And that's not like cheating or plagiarism or something. That's just learning by example. But every example is not necessarily going to work for you 100%. So you have to fix it anyway to work for your purpose. So here's a document.write. Look, there's a table. So in the document.write, in the loop, we're going to create a table, and then in the loop, we're going to add to the table body, and we're going to add to the table data and table rows inside of the loop. So we can create a table dynamically by looping through the body sections after we've defined the table. And then at the end of the loop, we can close the table. So down here on the bottom, so here's our loop here, which is going to populate the data that's going to show up in the table. And then down at the bottom, we're going to close the table body and the table. So we start the table up front. And we're basically using a document right here again because we're doing this all inside of JavaScript. And so we're going to document write a table border. We're going to set the border. We're going to set the caption for the table header is going to show up on the top of the table. And then we're going to align the table. We're going to set all the parameters we want for the table. And then we're eventually going to say a table row. And then for the table row, we're going to start the loop. And the loop is going to be, for each one of the iterations of the loop, it's going to create a row in the table listing the year of the loan and the amount of the loan. So we're going to go, we're going to print out the amount that's going to be equal to the principal times the math power. We're going to do the calculation for the year of the loan and for basically the amount of the loan that's going to appear. And then each one of the rows is going to be populated, and then at the end we're going to close the table tag. And if we close the table tag, it'll complete our table, and it'll give us our final result that looks like this. So we have, this is done in a loop. So a lot of people try to do, create the table first, then loop through the data to find what you need, and then add the data to the table. That's a programming technique, not a JavaScript technique. So in a JavaScript, in a text format for a script, you want to set the tags first, populate the table, then close the tags, which is kind of interesting because you're going to do this for everything. So as an example, you have an options list that's going to show up. You're going to start the option. You say this is going to be my new item, it's my new GUI item, and then you're going to loop through something. You're going to do a query on a database, for example, and then come back and say here are all the classes that are being offered. And then for everything that comes back from this query in the result set, you're going to add to it table component or an option component, option item 1, 2, 3, 4, and maybe set a default all within a loop, and then you're going to close the option. Or you're going to close the element or the list or whatever it is you happen to be creating. And then what you're going to see on a screen is going to be something like that, all finished. So you have a drop-down list box that has all of the classes you've taken in it, or you've got all of the data populated into the structure automatically, which comes in handy for a lot of stuff, especially when you start connecting and using this to look at a result set that's coming back. You can do it in Java. You can also do it in PHP, Python, all those scripting languages that work with databases as well. So this one's called the switch test. And in the switch test example, we're going to use a structure here where we're going to say for the title here we have switch, and we the variable choose is given. So variable choice, is given the value of the input by the user from a prompt. So it's going to say down here it's going to say window.prompt select a list style. And we're going to have a list that comes up that you're going to select from. And how we're going to get the list? Well, it's going to be bulleted items that are going to be populated. And then we're going to use a switch statement. So this is kind of the interesting comparison again. So we've looked at while, it goes endlessly until some condition is met. For, that's counter controlled, so the for was counter controlled. Switch is multiple selects. In the old days it was multiple select. So if it was A, B, and C, or maybe it's just A, or maybe it's just B, and if it was a single select, then you put the keyword break next to it. If you didn't have if it wasn't a single select, you leave the keyword break off of it, and then ends up happening as many as apply actually work. So a lot of people actually misunderstand the switch case construct, and same thing with programming. You see this with C programmers and Java programmers all the time. They'll leave out the breaks because they won't understand that this is a multiple select construct. It's designed to have multiple ones actually happen. And then there's a default at the end if none of them apply. But all through the years, people try to make it, single, which is fine. Also works for multiple option select. So in this particular case, we're using it for multiple option select, and it's a choice. So the value of choice here is being evaluated. And so in this particular case, it's an integer value. It could also be a character value. And so we can put in here, for example, switch character, and then if it's A, B, C, or D, they selected menu item A, they selected menu item B, or something. So here we have the break statement that causes the program control to proceed with the first statement after the switch. So we have case 1 colon start tag, end tag, the list type is going to be a bullet list. Case 2 is a start tag is this, the end tag is that, and then we have the list type is going to be an ordered list. So we're gathering up information, we're setting variables to equal information depending upon whether or not the user selected bulleted, ordered list, or something else. And then continuing on with the example here for case number 3, it's going to be an ordered list for A. So it's going to be starting out with alpha characters instead of numeric characters. And then as a default value, it's going to say valid input is equal to false, which is going to set a flag. It's going to say, hey, this is bad, and the user needs to enter something else in now. So if none of the cases match, the variable is set to false, which is interesting because it'll go through each one of the cases until it finds something, and the break's going to stop it at that point. If the break wasn't in there, it'd go to the next one, and go to the next one, go to the next one. But because the break's in here, it's going to stop and it's not going to do the defaults. If we want the default to happen automatically, we take the breaks off, and then the default's going to happen if none of the other ones actually, if none of the other cases work. But this particular case is going to happen the same way. So the breaks don't really affect the value of the default unless something is caught, and then the default will never be evaluated. So if a valid input here is equal to true, which it should be if it's not set to false during the loop, do something. So if the user uses it, valid input was created, then the list type, we're going to write out the list type with the start tag. Well, what did we do? We took this is HTML code that we put in, and we said start tag here is going to be equal to this HTML code. So we just write that to the screen. When we write it to the screen, we're in a roundabout way, taking a variable that has HTML code, writing the variable to the screen's going to interpret it as HTML code. And so we're writing HTML text in JavaScript using variables and document write, which is kind of interesting actually. So we're dynamically creating a list of the type that was selected from the prompt. So usually, what kind of list do you want? Bullet list? Okay, then it set all the tags to the bullet stuff. So it's going to print the tags out, then it's going to print out the list items that are associated with it. And how is it going to print out the list items? It's going to use a for loop. So if the user's input is valid, the list is going to be created, and then we have the for loop here, which is just going to write out the data items, and then it's going to put the end tag at the end. And the end tag is going to be the tag associated here, the end tag up here with this particular item, if the user selected case number 3 in this particular case. Else, we're going to write out invalid input in the choice. So otherwise, the message invalid choice is going to be displayed in the browser. So then click refresh or reload to run the script again. It's going to be printed on the bottom. So here's really what it looks like. The user's given a prompt, and the prompt's going to be equal to this, enter script type. So 1 for bullet, 2 for numbered, and 3 for lettered. So it's going to be alpha characters or numeric characters for the ordered list or the unordered list, which is going to be the bulleted ones. So we selected unordered. So the user entered in number 1. And then now we have a list item here that says number 1, list item number 1, list item number 2, list item number 3. If the user selected 2, it would come out with 1, 2, 3. And then if it selected 3, it would be ABC for alpha characters because it's lettered. And then on the bottom it's going to say click refresh or reload to run the script again, which is kind of interesting because if you reload the page, the script runs again. So one of the things you get with flow control and you get with interactive event-driven behavior, nothing happens automatically until the page loads. So when the page loads, this prompt comes up and prompts the user at the beginning. What happens if the user's already done that? That's when you have to figure out, well, I need a form now. I need something where I can put a button out here that says do it again. And so the button would initiate it through an action that was associated with a button click. So not quite like programming when you can set up a loop and the page just kind of sits there and waits for user input and put user input in, and it kind of, not like that. That's more dynamic. This is static HTML with dynamic behavior occurring, but the environment's not dynamic. So HTML is static by default. Web pages that come up are static, they're fixed. JavaScript used with HTML just automates static behavior, which is kind of weird. So you can't create the dynamic, so you switch to a different programming language. You switch to a different scripting language if you want dynamic behavior to occur. So how do you do that? PHP, Python, Perl. You can get more dynamic behavior occurring because you have more interaction that's going on, more user input. So it's a fully running kind of program, and those are usually run, well, all of them run on a server instead of a client. So you have a little bit more flexibility, so that's why people pick and choose different scripting languages, because you have to get the one that's going to suit your needs for what you want. JavaScript's nice for little stuff like this. Don't know if I'd write a complete program with JavaScript. So here if the user selected 2, in the example we have the 1, 2, 3, and then if they selected 3, we're going to have ABC, as I mentioned before. So that's the expected output that you'll see. So what are we looking at here is the flow control for the particular statement here for the switch. It's called a multiple selection structure. And we have case A, case B, case Z, going through each one of them. If it's true, do this break, which means go down to the end, we're done. If it's a false, keep going down, so, which is basically the flow control that we're looking at in terms of the structure. And theoretically, if we don't put breaks in there, this break tells us to go to the end. So if we don't have the break in here, it's going to keep evaluating. Because what if more than one of them is true? If more than one of them is true, what if we were doing like integers and we were saying less than 5, and we have 1, 2, 3, 4. Well, all of those numbers are less than 5. So we would have 1, 2, 3, and 4 working. So think about it as a multiple selection option. So when you're trying to decide, well, which one do I want to use? If you have multiple selection, this is probably the most preferred method. instead of going if this and then inside of the if this too, and if side of the if this too, is you can take this here and divide it out and use it, if then construct, where you've got nested ifs for each one of the conditions, and then you've got, for each one of the conditions, you've got each one of the other conditions also nested inside of it. So you've got about 10 times the complexity than if you were just to write it this way. So sometimes the choice of the control flow structure has to do with making it simple and easier to understand the loop and what's going on with it. So here's another example. This is a do-while test. So before we saw the while, and the while just while something. A while has the option of not actually running. While the input's true, okay, the input's false. So the whole entire while script is going to be completely avoided. And so it's not going to run. And the way you're going to figure this out is you've written this beautiful little HTML page with this little JavaScript, and it doesn't work. Why doesn't it work? Because you never initialize the variable. Why do you initialize the variable? Well, because you had a while loop come up and the while loop's not ever running. So it's usually the value that's being evaluated for the while. So if you want to avoid that problem, you can do a do while. If you do a do first, it's going to do it no matter what. And then you're going to initialize that variable right there. So the variable is initialized first, and you're guaranteed one iteration through the loop. So it makes a little bit more sense depending upon what you're trying to accomplish in your code. So here's our do. So for each iteration in the do while loop, write a line of text with a header element and an X HTML document. So here we're going to have a header header element, and so the loop's going to stop when the value of the counter is greater than 6. So we're going to get 0, 1, 2, 3, or whatever we start it with. So actually it's going to do, the counter is going to be equal to something. And we're going to put the counter in here, and we're going to increment the counter, and then while the counter, and here we have the while down here. So we move the while from the top of the loop, put it on the bottom of the loop, and to start the loop we do a do. So the do is the key word that's going to start it. And then we have the opening and the closing brackets here. And then we have while outside of the do, because it's going to go from the beginning of the do to the end of the do, which is that opening and closing bracket. So most people, when they do this, they make a mistake and they put the while before the end of the do. So inside of the do, they have the while going on. Well, you want to make sure that the do is complete before the while even starts. Otherwise the do can't finish and you're going to get an error message that comes up. Actually, in this particular case you're not going to get an error message, just nothing's going to happen. The problem with JavaScript, very little debugging. It's not a programming language. So when you run the page, nothing's going to happen. It's going to look beautiful because your HTML code is perfect, but your loop's not going to work. And why isn't this working? Or you can't even tell if the loop's working or not. All you know is the functionality is not working. So then you have to go, well, what's going on here? So a lot of people write little stuff, loop started, loop ended, little notes to themselves that get printed on the screen for testing purposes. And sometimes that stuff actually stays in, so you see it. The loop executed. And you're looking at this form going, okay, great, my shopping cart and my loop executed. Perfect. My shopping cart was read correctly. Okay. So here's the H1 level header, H2 level header, H3. Because we're decrementing the loop, we started with 6 and we're going down to 0. And so we just basically did it in the exact opposite order. So I believe the counter here, while it's less than or equal to 6. So it's going down 6, 5, 4, 3. Oh, no. Well, actually it's going up. You're right. It's going the opposite direction. So 0, 1, 2, 3, 4, 5, 6. We're done at that point, or 1, depending upon what we started at. The initialization right here is behind the comment, so I can't tell what it was initially. Probably at 1. Actually, it was at 1 because we're taking the 1 here for the counter and we're putting it in here. So we're concatenating H1, H2, H3 right here. Actually, it's kind of hidden behind the comments, but it's there. So the do while repetition sort of looks like this, where we have the actions. And it comes down to a condition. If it's true, go back up and do the actions again. Go back up and do the actions again, which is why you want to close off the do before you start the while. And the while is the condition. And then if the condition is false, it stops. So, which is the logic for the flow control and the repetition. So now we have another one here. This one's called a break test. And so we're going to put a break in here. And this is the interesting part. So a lot of people think that And there's actually a continue as well. There's a continue and a break. Most people have never even heard of the continue though, because they don't use it for some reason. But it's nice in a loop to check a condition and then continue. Check a condition and then continue. So it's also possible to put a break inside of a while loop or DoWhile loop or for loop. So they're not restricted to case switches. So most people learn the break from the case switch. They put a break in there. But what if you want to break a loop after first, maybe you have multiple tests inside of the loop and you want to break after one of the tests. So the break can be used for multiple select in other situations. So in this particular case we've got a break being used here, using a break statement. So when the value of the variable count is equal to 5, the break statement causes the program control to proceed to the first line outside of the for loop because it's going to break the loop. So here's the break. So inside of this loop, we're not going to use the for counter. The for counter is going to go up to 10. So the for counter says variable counter is equal to 1, counter is less than or equal to 10, plus plus. This loop's going to go 10 times. It's a counter-controlled loop. But it's not going to go 10 times because we put in here, if the count is equal to 5, break. That's going to stop our loop after 5 times. So here's the other thing that comes into place. You put together this really lovely little control structure and it's working just fine. But it doesn't go 100 times. It only goes 5 times. Because you put something in there where it said go over here or do that or run a function and the function failed and it never returned back to the loop. Something stopped it in between. You can also do continue, not in this example, but if you put continue in here, you can continue from errors, you can continue from problems. As an example, you went and did a query, but the query failed. So you don't have anything to populate into the list box. So you can say, if the query failed, set the list to equal to default, which is going to be, generic stuff to put in the list box, and then continue. So you fixed the problem, and then now you're going to go ahead and populate the list box with the items that are not from the database. They're just default stuff. Maybe it says unknown, 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 or not paid, not paid, not paid, because you don't have any amounts that were paid or something. So here's the break, and if we do this, we're going to get on our counter control loop that was supposed to go to 10. We only went to 4, 1, 2, 3, 4, and then it broke up the loop at count 5 at the end. And the broke up the loop at count 5 is actually printed at the end here. So the loop ended. Then we took the value of the counter, which is kind of an interesting thing. It's visible. The count is visible at the end of this loop. It's in the same scope as the rest of the page. So we can come back and say, well, what is that count? And further down the road, we can figure out how many counts were there. So let's say for a shopping cart, we can count up how many items, or we can keep a counter on how many items every time someone press add, which is how it's usually done. And then you have items if it's more than 0. So you know that you're going to put the item number, and that's actually kind of easy. You can put a little icon up there, a little shopping cart, and put a number next to it. And it'll say 2, 1. How many items did you add to the shopping cart? It's just a counter. It has nothing to do with what's actually in the cart. Sometimes the counter is actually wrong because you said I wanted 2 of one item, but it's only 1 item. But the quantity is 2. But you actually have 3 items in there or something when it only shows 1 or 2. But it's not used for that purpose. It's used to present with the HTML code using JavaScript or something similar a count to say, hey, you got something in there. Do you want to check out now? And so it can take and say, well, if the count is more than 0, then illuminate or make the checkout button visible. When you're like, where'd that checkout button come from? Oh, the program knows that I have items in my shopping cart. So, which is, a good user interface kind of technique, because JavaScript in some ways is used for user interfaces. It's used for anything on the client side, for form checking, UI design. Oh, we want to put the customer's name on the top of the page, or we want to put a lovely little count for the shopping cart, or we want to put a checkout button or something. So you can dynamically populate the page using JavaScript for certain things, and you can keep track of counters and stuff like that. So, giving you the reason why we're looking at this. Here's the continue test, as I mentioned before. So on a continue, so when the value of the variable count is equal to 5, continue statement is going to cause the program control to proceed to the next iteration. You're wondering, well, why do we want to put a continue in there? Because what if we want to write something special to the screen, like number 5 was hit? Because number 5 actually got encountered during the loop. We found number 5, put it to the screen. So to check for something like, let's say for example you put 5 items in the shopping cart, and then you notice that, well, one of the items is, actually Amazon does this, one of the items you can get free shipping. So it can check to see, oh, no, just like number 5, oh, free shipping. And then once you put something that said free shipping in there, the loop can stop and do a calculation and say, hey, how many items do you have in here? If the dollar amount goes past a certain amount, the whole order gets shipped for free. And this is actually the case with Amazon, believe it or not. But you have to make sure it goes over a certain amount, or you've applied for the Visa card, or whatever the condition happens to be. So if that's the case, then print this to the screen, let the user know that they're very close. They just need to apply for this special Visa card or something, or they need to add another item in so that their dollar amount goes up over $100 or something. I don't know what it is, don't quote me on that, but the logic is done and can be easily done with JavaScript by putting a continue in there to check on a condition. You still want the customer to continue, but what you're looking at is the ability to kind of change the UI, change the options that are available, change the interface given what the user's doing. So, well, we found out you did something. Continue doing your stuff, but we're going to make this special case for you because you're doing something special or something. So here, skip the remaining code in the loop only if the count is equal to 5. So if it's not equal to 5, we're going to continue. So we're not going to stop on 5. So in a for loop here, we're going to paste, in this particular case, we're not doing anything too fancy. We're pretty much doing the same thing. But use the continue to skip printing number 5. So it's going to print something out, but it's going to continue if count is equal to 5. So what we end up with this results here is 1, 2, 3, 4, oops, no 5. 6, 7, 8, 9, because we caught the 5. We caught the 5 here. We said if counter is equal to 5, continue. Well, continue says go back to the end, come back all the way up to the front. It skips everything else. Like the break skips everything else. So does continue, but the break takes you to the next line after the loop. Continue brings you back up to the start of the loop. So we never printed out number 5. So what we do if we were doing this, we put, okay, print out number 5 in there, but also tell them that they have free shipping. Or change something else on the screen to make it more interesting or more dynamic. So to continue, it works in those cases as well. So this example is called the break label test. So we're going to check a label, and then we're going to break. And we're going to go to a label. Actually, excuse me, and here we're going to go to a label. So remember go-tos? Hopefully none of you do. They're really bad practice. But you can break, so jump to the end of the stop block. You can actually use a go-to in here too. You can still, the word go-to is still supported actually in JavaScript and some other languages as well. It allows you to say, well, where do you want me to go to? Or where should I break to? Where should I break to the end of? Or where should I go to? Which gives you a little bit more flexibility again. So here we have stop. Stop colon. So just as we break to stop, we can go to stop. Why do I want to do that? Because what if you found out that the user doesn't have enough money on their credit card and you are processing their amount and the secure processing system came back and said declined? Uh-oh. Then you want to cancel the order right now and you want to go to a decline block in the code, in your JavaScript code, and you're going to say, your card was declined. Would you like to try another card? And if the user says yeah, then you're going to take them back to the enter a new card information and reset all the information so that they're starting brand new, but not back from the beginning. They're just starting brand new back to the card, enter the card information, and then they can bypass all the rest of the stuff. The worst thing for a user interface is it was declined. Start all over, fill the shopping cart back up, pick out your shipping method. Some interfaces, believe it or not, do that, which is really primitive, because they don't know how to actually control how far we're going to stop and where we're going to start it back up again. because we're not using go-tos, and we're not breaking to certain breakpoints, and we're not defining blocks in the script. So we're just, oh, we're done. Start back over again, which is, ridiculous. So here, better control, long story short. So the stop is a label for the break statement, which says stop right here. So when the break statement is encountered, the program control proceeds to the first line outside of the stop block, and not just for the for loop, but all the statements that are inside of it. So it can stop here. What if the stop block wasn't here? It can be way up here, it can be way up there, it can be anywhere in the code actually. It just goes to that label. So in this particular purpose, the stop here is to go back up to before the for loop actually started. So in here, if the row is equal to 5, I know we have this really functional code here, we're going to break to the stop, so it jumps to the end of the stop block, and the end of the stop block is going to be wherever this code ends, right here, down here on the bottom. It says the following line is skipped because the line should not print, because we're not going to go to there, we're going to go to the bottom of this area here, which is down here. So it's not going to break out of the loop, it's going to break out of the block. If we wanted just to break out of the loop, we put break in there. The block here starts here, ends here. So when we break, we're breaking out of the entire stop, or the entire, block. It's actually, I said stop, but I meant block. Block of code that we've defined for this function. So here it is here, program output on the bottom. It's going to print out, it's not going to print out end of script, instead it's going to go end of script, which is at the bottom. Excuse me, it will print out the end of script because the end of script is after the stop block of code. But it doesn't print out this line, it should not print, because this line should not print, actually. Okay, so here's a continue label. So instead of continuing in the loop, we're going to continue from the start of the label. So now we have continue next row. So here, the next row is the label for the continue statement. So just the same way as we had stop here, next row is going to be, this defines a block of code, by the way. And so anything at the beginning until the end of the block is included inside of what we're defining as the block. So here we have the target label next row. So here it's covered up, so I'll just read you what's in here because we can't see the code. It's behind the comments here. But if the value of the variable column is greater than the value of the row, and the continue statement causes the next iteration of the loop, and it will continue to, and this says next row next to it, so to continue to the next row. If the continue next is performed, then the document write does not print out the asterisk. So because it continues up to here, it never gets to this line. It will continue back up this way. So instead of breaking, we're continuing. It's the same thing as before. Each iteration is going to print an asterisk to the screen. In this particular case, which is what we're getting. So the output isn't as good as, isn't as useful as knowing that the continue brings us back up instead of back down to the end. So break will always bring us to the end of the block. Continue will bring us to the start point in which we started with, which is going to be at the beginning in this particular case. So we could continue to a checkout failed block, and the checkout failed block doesn't have to be the same block. We can continue any block we want. So the failed block can say, hey, would you like to retry your credit card information? And then restart, continue at that point instead of continuing out at the end of the process, at the beginning of the where you started with. So this one's called logical operators. So this one here is an example of using the ands and the ands and the ors together, which are the logical ands and ors. So every expression will be evaluated to true or false using the rules of the logical and it's two ands together, which gives us the logical operators. And then here we have the opposite, or the ors. So each expression here will evaluate to true or false using the rules of the logical or. So here we have false and false, false and true, true and false. So true and true is true. True and false is false. False and false, true. If they both match. This and this, so if 5 is less than 10 and 3 is less than 10, that's a true, true, true. But if 5 is less than 10 and 12 is less than 10, no. And they both have to be the same. So if this is false and that's false, well then it's true. Yeah. But the logic actually in this JavaScript doesn't work that way. It works in some other languages, it doesn't work that way. So if it's false, false, it's false. In this particular case, not to confuse you. But the logic is actually interesting because it does vary between programming languages. The or is the interesting one if we have one or the other. But if we have true or false, then we can go if one of them is true, one of them is false. So depends on what you're evaluating as well. So this particular one is just demonstrating logical operators by printing them to the screen. Not really doing anything. It's just doing this. So here's the logical and. False and false is false. False and true. False. No. False. True and false, false. True and true, true. For the ands. The ors. False or false is false. False or true is true. True or false, true or true is true. So, true and true is true. Or the not. So, not false is true. Not true is false, which is the opposite. So a lot of people like to use the nots because it's a little bit easier. And what are you doing? You're evaluating a Boolean, true or false. Well, what's the Boolean? The logical operator expression can be an evaluation. So it can be 5 is less than 10, and that's going to come out as true or false. So you put 5 is less than 10 inside of the expression, and what the JavaScript is doing is it's evaluating true, true, false, false, and it's coming out with what might actually be the result from that. So here's the summary of the structured programming in general. We have repetition, we have selection, and then we have sequences. So in terms of the repetition, it's the while loop, the do-while loop, or the for structure to repeat. For the selection, we have the if and else that we talked about last time, and the if and else structure with a single selection, or multiple ifs, else's nested within themselves. Or we also have the switch statement that falls into the same category. So it's part of the selection. And then we also have the sequence, which is this to this to this to this. That's our breaks, and our continues are giving us our sequence of statements. So this is really what's referred to as the structure of the program. So it's structured programming in terms of the constructs. Unstructured flowcharts goes everywhere. And most people write unstructured because you're not going to have a program that just tests to see if something is while. That's easy, actually. To combine them all together, then you have something where the flow is going to change depending upon what you're doing. So here we have a start with a decision, with another decision, with something that's going back to something else, which is what you may not necessarily be working with a completely structured environment for the most part. So the next topic for today is functions. We've seen functions, but let's just put them together in some examples. So past the syntax of the function expression, which we've already covered, we're going to see examples of it applied with flow control and with other things to see the big picture. So the program module in JavaScript comes out with a main, and we have worker 1, worker 2, worker 3. We pretty much have a hierarchy of functions so that we're going to work with. So the hierarchy of the boss function and the worker function relationship is demonstrated here, where you have workers with a boss up here, which is also a worker. And just checking the time. There we go. So what do we have here? This particular example is called square int, calling the function square and passing in a value of an integer. So just to review the concept for you, this is an inline function. It is one that is written in the code, or is it not an inline function? Well, let's see what we're doing here. In the title, in the head section, we're saying we're writing a script, and the script here is going to be a JavaScript text type, and our function is down here, so this would be called an inline function. Inline because it's inside of the it's just like inline style sheets. In the header, we're going to put in there the style. We're going to put in there the function, so it's in the code itself. Perfectly fine. You can do it this way, or you can put it in an external file, read the file in. which is more common these days. Then you can reuse the function in multiple HTML documents, not just this one. So here we're going to call the function square and pass it an integer. Well, how do we do that? We're going square x. So we're putting the value of the integer. Where's x coming from? X is what we're using here in the function. So the square of the numbers from 1 to 10. So I was mentioning before, this is using iteration along with functions, and I'm putting all the pieces together in terms of creating some functionality. Down here, way down here, we have the function. So essentially we're calling the function before we even declared the function. But it's all within the same block of code. So you see the head down here, and you see the head up here. So that's within the same block of code. It's within the same. Not so typical. Not so typical, but if you're doing writing a page that's only doing this, it makes sense. Actually, it works. It's not illegal, but not very typical. So here we're going to, the variable y gets the value of x. So we say function square y. Why didn't we use the same one? Well, interesting case is we don't want to confuse. So using x and y is actually not a good practice. We should say input, output, integer value, square value, or something to make it a little bit more meaningful. So this example is kind of odd in a lot of different ways. We're going to return y times y because we're going to square y. So within inside of the function y is the variable. X is never referred to, x is never changed. We just passed x. So for those people who know programming, this is called by value. We're calling the function by the value that we're setting to. It happens to be a variable. We don't have references. There's no pass sorting, there's no call. There's no pass by reference in JavaScript. We don't use pointers either. So we just do values. So it's kind of easier, actually. So if you don't know what I just said a few minutes ago, then forget it. You don't have to worry about it. But if you are familiar with programming and using functions in other languages, this is passed by value or called by value. So variable y gets the value of the x that gets substituted in here. Then the return statement passes the value, which is why it's a pass by value, and this is a call statement actually, and this is a pass statement, which is why I said both. So. But you're not going to know that unless you've done any programming. So the return statement passes the y times the y back to the calling function. So here we have square. Well, it's going to pass this and substitute the value in here plus this here. So classic example of running a function. This function isn't really doing very much, but if we wanted to square things on a regular basis, it makes sense. So functions come in handy when you want to do repeated code over and over and over again. And you don't want to write the code over and over. You just write it once, put it into a function, call the function, and run it that way. So here's square the numbers between 1 and 10 inside of our loop. We have 1, 4, 9, all the way up to 10. So, kind of trivial output, but it's just a simple demonstration. Here's a maximum function. And we have down here on the bottom, we have function maximum, where we're going to take a list of values x, y, and z, and we're going to figure out, well, which one is the maximum value? So max returns the larger of the two integers passed to it. So the prompt for the user to enter in 3 integers. So we've got prompt, enter first number, second number, third number. And then we have the call for the maximum. So we're going to pass the values of variable 1 and variable 2 and variable 3 to it. So maximum variable 1, variable 2, variable 3. And we're going to assign this one to equal max value. So a lot of times when you run functions in JavaScript, you're going to assign it to a value of a variable because you want to use the value and you want to capture the value. If you just run the function, great. Some value is returned. So what are you going to do with the value? So usually you're going to assign it to a variable. So you can do it in one step rather than breaking it out into multiple steps. And then down here on the bottom, the method maximum is going to return the value the maximum is, which is going to be performing the calculation. Don't worry about the calculation, just know the function is going to give you the maximum value coming out of it. And on the bottom it's going to say refresh to try the script again. So of a 12.35 is the maximum value. Here's just some maximum values being put in. It's just going to you're going to enter, you're going to enter in 3. Looks like 56 is going to be our maximum value. And then it's going to say first number was this, second number was this, third number was this, maximum value is 192. So it determines the maximum value out of 3. I believe the slide said 2, but it's actually determining the maximum value out of 3 parameters that you're sending it. And the concept here being that you're sending it an x, a y, and a z. You're sending it three values. And within these 3 values, it's going to determine which one's bigger than which one by using a max function. You say between this one and this one, which one's the biggest one? Which is all the functions actually doing. And you'll figure out which functions exist in the math and which functions exist in the strings and all of the other built-in functions for the objects once you figure out a need for it. So once you figure out, well, how do I get the maximum value? Know that math.max is going to be, there's going to be a function in there. Most people just get books, look up things when they need it. Another interesting one is the random integer example. Random, believe it or not, comes in handy for a lot of different things because people want to play games. You know, they want to randomly roll the dice and pick 2 numbers between 1 and 6 on each one of them, including 1 and 6 or something. They want to come up with, guess a number between 1 and 5, and then randomly guess one, and then have the user randomly guess one and see if it matches. Little games and stuff like that. Or for sorting and searching and things, just randomly selecting something. How about this one? So shift and scaled random integers, shifted and scaled. So here we have a for loop that creates 4 rows with 5 cells of a table. And the method floor rounds the numbers generated by the method random. The floor here is going to round it down actually. So ceil takes it to the highest number. So if it's a 4.4, then it's going to be 4. So if we get a random number, 4 points, we're going to round down. Or if we're going between 1 and 5 and it's 4, past 3 or past 2.5, so it's probably going to be, if you round it down, there's no rounding on that one. If it's 5, well, if it's past a certain midpoint, it's going to be rounded up or it's going to be rounded down. Floor rounds it down, ceil rounds it up. So here, math.random picks a random number for us. So each cell is populated with a random number generated by random. So we can get a random number that has precision to it, or we can get a random number that's an integer value, depending upon which kind of random you're running and how you're creating the ceil or the floor, or how you're creating the randomness. So here, for I is equal to 1 and I is less than 20, we're going to do this 20 times. We're going to run I plus, we're going to concatenate this. We're going to 1 plus this random number times 6. So we're going to essentially make this a little bit more interesting. Then we're going to write the start table row tags here, and then I is a multiple of 5 and not 20. So I is a multiple, it's going to be equal to 0 as in terms of our test. And if it's not equal to 20, then write it out to the screen. So we're going to get the ones that are not 20 and they're not multiples of 5. It is a multiple of 5. So when we write the information to the table, we get random numbers here, and then more random numbers here, depending upon, each time we run the program, we're going to get different random numbers that are going to be populated in the range that we're looking at, which I believe stops at 5, so it's 1 to 5. No, actually down here we have a 6, so maybe it's 1 to 20. Anyway, long story short, the program output gives us a table with random numbers by combining the random function of math object along with a for loop that's looping through here for I is less than or equal to 20. So we actually have 20 values in here, but there are 5 per row. 1, 2, 3, 4 rows, so for 20 values total. And here's our next one. Let's just roll a dice there. As I mentioned before, it could be used for rolling dice. So this one's called Roll D, if you want to find it. So roll a dice-sided, a 6-sided dice 6,000 times. Oh, that seems pretty bad. So here we have the expression for the face, and the face is going to be in 1, 2, 3, 4, 5, or 6. And I believe 6 is going to be up here. 5 and 6, 6 is on the next slide here, 6. Because we have 6 faces to the dice, which are 6 integer values. So when we do our randomness, we're going to do our randomness to go up to 6. So it goes from 1 to 6. So the expression here uses a method random to generate numbers between 1 and 6, which is going to be here. So in terms of the for loop is going to summarize our results for us. The frequencies are going to be temporary variables and keep track of how many times was this number rolled for the 6,000 times that we ran it. And so we can get the frequency of the randomness. And when the controlling expression, the face matches the case label, the respective frequency variables incremented. So here we're going to have, frequency 1, 2, 3, 4, 5, 6, depending upon, if that number was rolled. And the face is going to be equal to the face floor 1 plus the random. Under here we have the random number that we're seeding 0 through. You can't see the code because it's hidden by the label, the message, but it's going to basically call the function to select a number between 1 and 6. And then for each one of the faces that comes back randomly, we're going to keep track of how many times it came back. And so up here we have the table border that's being created, and then we're going to have the table information, and then we're going to put in here the frequency. So after the loop is already done, so it went through 6,000 times or so, and how many times we set the loop to go for, it's going to randomly roll the dice. It's going to give us all of our rolls in terms of the number of frequent times that each one of the rolls, each one of the faces occurred. We have all the data now, so we're just going to print out those variables. We're going to print it on a table. So we're going to document right, the table border, set the table header to faces, and then to frequencies for one column and the other column. And then print out the variable for frequencies. And then if we do that, it's going to look something like this. So it looks like 5 is rolled a lot. Is it really statistically correct? Who knows? It's the random number that's doing it. And then down here we have 5 and 4. But wait a minute. We have 2 down here. It was rolled a lot. So there's a book out there for people who like dice games. There's actually a book out there that says that. Well, the thing is, this is one dice, one roll of a dice. We take and add 2 dice to it. There's books that do the statistical analysis on the frequency of the combinations. It's because of the number, how many times the combination of the numbers can exist, which is going to increase the frequency. It has nothing to do with randomness. But when you think about it, is it really a random game? If not really a random game, if you're playing with 2 dice, you're building off more of the frequencies of the statistically, how do you get the combination of the number to appear? Like how many times you're going to roll a 7. 7 comes up more often in the combinations, which is why it's used for craps. There's a gambling game called craps, where if you roll a 7 on 11, you lose, but the 7 comes up more often. So you can play craps with a counter bet on an 11, and you win if the 11 is rolled before the 7. So that's the best bet, I think. Or so I think they call it snake eyes, the 1 and the 2s that never come up, but they're like 32 or 30 to 1 odds, because the odds are based upon the frequencies that are going to come up. So if you study the frequencies and know how often and which numbers come up more often, it takes the fun out of the game because it's predictable. So some of the people who like, dice games as an example, or cards, you can do the same thing with 21. Or you can do the same thing with the odds of the combinations of the deck and the cards, just by counting the cards. But who's got the brain power to count the cards? Nobody does, unless you're have this autistic, or you have this. Usually you have a mental condition that allows you to do it normally, and then they don't let those people in the casino because they'll always win, because they can count it up so they know which ones are going to come up next. The same thing with the dice, actually. If you can count the rolls statistically with the combinations and bet statistically in your favor, you're going to win. So now, here's craps right here, by the way. So craps is a game of throwing 2 dice together to come up with a combination. And today we're learning about gambling. So next time you go to Reno, you guys gamble? No? Sometimes? There's gambling clubs here, but they don't play traditional games. There's some in Mountain View, if you know Sunnyvale, Bay 101 Club. They play a lot of the Vietnamese games, and like Pai Gow and Chinese games, Asian games. Not really the craps games or the card games like the blackjack or the 21, but they're very similar in terms of the concept. In fact, you can usually win more, not to promote gambling in HTML, CSS class today, but statistically you can win more on those games if you understand the game. The problem is those games are so complicated. Plus they keep rotating the decks. That's the thing. So that you'll see on a 21, if you're winning, they'll keep swapping the deck out. Because they'll change the deck so it's not as random. So you can be assured that you're not going to go through an entire deck. You're going to go through half a deck or a third of a deck. Which means it makes it impossible to count to see what statistically is going to come up next, because it ruins the scale, makes it in the favor of the house. So what you want is the same deck being used from the start to the end. Never going to happen. Because if it is, then you could actually play it right. So craps. This is the game with the 2 dice. You roll the dice. So the variables are used to test the state of the game. The game is a won, a lost, or continue rolling. So you roll a number, and then the game goes with, if you roll a 7 or an 11, before you roll the number again, you lost. If you roll the number again, before you hit a 7, you win. Before you hit a 7 or 11. So if the first roll is true, then the function of the dice, roll dice, is called. And actually, if you roll a 7 coming out or an 11 coming out, you instantly win. It's just that you can't roll it after you've rolled another number, which is actually a pretty easy game to play. And then the big old board, you just put chips on the numbers. You're just playing the statistics of the numbers. Anything you put out there is a sucker bet. Because the people that really play it only play the 7 or the 11 or anything else in terms of the odds of that happening. So, but then they have the bust line. So craps is actually kind of an easy game to stay neutral and play for hours on end without winning or losing. Because you play the odds of it coming up and then you counter bet it. So if you make those equal, you'll break even on every single roll. Because it's the come or the don't come. You're either going to come up to the 7 again or you're not going to come up to it. So you play against yourself and then you win. Well, or you lose and you always break even. You're going to win one and you're going to lose the other. So, but you can play that for hours. It's kind of boring though. So you don't want to do that unless you're just waiting and killing time. Back to craps in JavaScript. So here we have some variables that are going to be used for the state of the game. We're also going to have variables to be used for the first roll. If the first roll is true, then we have a first roll. We have a number that we're going to hit. Some of the dice is going to be 0. My points is going to be 0. The game status is going to be continue, or it's going to be you lost or you won, depending upon what state you're in. So we have the process of one roll of the dice. So it's going to be function play. So play is going to happen first. So if the function roll dice returns the value of 7 or 11, the player wins on the first roll. So because if you roll 7 or 11, you're automatically going to win. And then the break statement causes the program control to proceed to the first line after the switch structure. So if we get a 7 or 11, game status 1, clear the points, print out, break it. So if not a 7 or 11, if it's a 2, 3, or a 12, you lose on the first row as well, because that's called craps. You can't roll a 2, a 3, or a 12 because you're going to crap out. So you don't have to worry about knowing how to play craps, but if you do know how you can run this game, it's actually kind of funny. You can play craps with yourself. So the game's going to be a lost if you roll any of those numbers on the first roll coming out, and then you're going to break. Otherwise, you're going to do the default. In the case of this program design, the default is going to be the game, and the default's going to be set the number. The point is 5, and then you have to roll another 5 before rolling any of this other stuff. And you can use the same loop, actually. You use the same case switch because all of the values are going to be the same, or you can modify the case switch if the rules of the game change. So here if the function roll dice returns, that's a typo, 2, 3, or 12, and the player loses the break statement clauses, control proceeds to the first line after, since I've lost in this particular one. And then down here on the bottom, we have an else. We have the sum of the dice. So if the win by making the point if the user rolls the same number again. So if the value returns a function of roll dice equals the value of the variable my point, the player wins because the point has been reached. So we have the test down here. Some of the dice is going to be, well, roll the dice. And the roll dice function, and this is actually kind of demonstrates the purpose of a function actually. The roll dice function is going to reset the dice faces. So we have two dice, and we're going to find the faces of the dice, and then we're going to add them together and see what number it is. And then if it matches the number we're looking for, then we've won. If not, if it's in a 7 or 11, then we've completely lost. Actually, the game runs with a 7. So you can still roll an 11 and you haven't crapped out yet, but if you roll a 7, then you lose. So, but a 7 is the most frequently occurring number in the statistics. So, alright, so a game status is going to be equal to lost. Then if you roll a 7, so the value returns a function roll dice equals 7, player loses. Otherwise, the player wins. So if the value of the game status is 1, then print to the screen player wins, and that's if they roll something that equals the sum of the dice that equals their point. So the sum of the dice equals the point, then they've won. And then we have the window which method status, which is going to display the message in the status bar of the browser. So it's going to put it in the lower end of the window or the higher end, depending upon how the status bar is configured on the browser. And so we can, function roll the dice is called to simulate the rolling of the two dice. So here, function roll dice. This is the function that selects the two dice. So the method random and the floor are used here to generate values of the two dice. So you do it twice. So it's just, is it random? Is it random? Yeah. So it's a random roll. And then the references the names of the form elements here. So we have document.craps.sum.value. So the form element for the sum, which is already in the form, is going to change. It's going to be a label that says sum. It's going to change with each roll. And we're going to reference it from this document object model. So we're actually using everything in this example all put together. We're using the document object model along with functions, along with function calls and random. So built-in functions along with our own functions. So here the values of the dice are being placed in their respective form fields. And then we're just going to do some rudimentary stuff. We're going to print a table out, say die 1, die 2, sum, points. So we'll put it into a table. And here's what it actually looks like here. So we've got the text here. It's going to say die 1, die 2. So we rolled a 6 and a 5 and equal to 11. So we have to roll again because we crapped out in that point. And then now we have a 1 and a 1, so the sum is 2, so the point is 2, so then we roll the dice again. So we have a button here on the form element that's going to populate out what the roll was. If you run this, actually cut and paste it, run it. Actually can create a little, you can create a little crap scheme for yourself. But I'm not promoting gambling. So now we have a 6 and a 4, well that's a 10, so now the point is 10. And so we're going to roll again, a 5, 5, 10, hey, we got our point. Roll is 10. So now we have a 3 and a 2, which is a 5. So we can roll again. So we just keep playing over and over again. It's just going to give us, this example is just going to give us the two dice faces, the sum, and then what the point is and whether it equals the point or whether it fails. And here's our continuation. We get a 4, a 3, it's a 7. Oh, that's point is a 5. So we can kind of see which values we're going to get. In fact, you can people have done this with simulations to see, well, actually you could do it yourself. You can say randomly, depending upon the randomness of it, you can do it yourself just with a couple of dice. And keep tabs, do it like 100 times, and see what the frequency of each one of the rolls is, and then do that test a couple of times, and you'll see it's pretty consistent. So then you can tell, well, what numbers come up? And then people get favorite numbers because of superstitions and stuff. But and if that's the case, then play roulette instead of craps. So, alright, so this one's called scoping. And it's going to look at local and global variables, just to reiterate the point. We've talked about this already before. But just to show you an example of it all put together, along with some functions. Going to run some functions in here too. But this adds in scoping components with functions. So variable x is equal to 1. So to begin the program, variable x is initialized to 1. And then we have a function that's going to say start. The function is called start. When we call start, it's going to say variable x is equal to 5. So this is a global variable out here. And then now we have a local variable to the function starts inside of the function. So unfortunately, JavaScript allows us to use the same name or the same variable multiple times. And we can use it with variable or without variable. But this one is giving us our function scope. So variable is declared with variable inside of the function is using the function variable. If we just said x without the variable, we would be using x from the global instead of the local. Because this is global and this is local to the function, not global. If we're using it this way. So the function start changes the value of x to 5. And then now we have some stuff that goes on in the function, and we're going to call, the function is going to call function A, B over and over again. And so here, function A changes the value of x to 25, variable x is equal to 25, initialized each time the function A is called. And function down here, the value of x is incremented. Function B is going to multiply x by 10. Let's see what happens when we run the function. So local x is starting at, and it's equal to 5. And so we have local x and function A is 25. After function A, local x is 26 after function A. Global variable x is 1 after function B, 10 after function B, and let's take a look back at function B and compare it to function A. Function B just is using x. Function A is saying variable x is equal to 25. And function B, it's just using x. So x is global here and it's local on the other one. So whenever you use the word var to declare the variable, you're declaring a local variable declaration. You're not using the global one that was declared previously. And believe it or not, on a global state, you can actually not use variable keyword. You just say x, because you can use variables with or without a declaration of the variable. So you can just say x plus equals 10. Well, you're actually multiplying out. In this particular case, in function B, you're using the globals. So function A in this particular example is using the locals. Function B is using the globals. And the local state is 5 at the end of this after it does all of its changing. So global goes 1 to 10, and it goes from 10 to 100 because we're timesing it by 10, I believe, in variable. Yep, here. So function B is multiplying everything by 10, and function A is incrementing by 1, I believe. No, it's doing the same thing, but it's local to the function. Well, every time you call a function that has a local variable, the value of the function and local variable resets itself every time the function is called. If you're working with a global variable, it stays the same through the life of the program to give you the differences between local and global. So that's why we can start out here, and you see the function A always returns the same value because it's always getting a brand new value every time it starts. So each iteration of the function, what happens in the function stays in the function. There's no history. Global 1, 10, there's history. It's global. So then if it's incrementing by 10, then now 1 turned into 10, 10 turned into 100. It's 10 times 10, 1 times 10. So we're maintaining the state. And the local state is always going to be initiated to 5, regardless, inside of the function A. So function A is incrementing it by 1, times it by 25 or something, I don't know. Timing it by 5, incrementing by 1, I believe it's doing. So you can sort of see the how that might come in handy in terms of global and local. So what are you going to be asked on the final exam for this course? Multiple choice questions about scenarios. And then you're going to say, is that local or global? No, actually I'm not going to ask you that. It's like, what's the value of x? Okay, something else, stuff like that. So that's one of the concepts you want to be familiar with. You know, what's a for loop used for? What's a while loop used for? Stuff like that. No, actually, I'm probably going to do mostly multiple choice on that. Meaning subjective, do you mean like fill in the blanks or something? Or do you mean like short answer? No short answer. It's easier for me to do multiple choice. Multiple choice is easier for you to. I'm sorry? I believe it's 25 points, and the midterm is 25 points, and the assignments are 25 points, and the CSLO is 25 points. I believe. At the end, I can check first, though. JavaScript, global functions. We have escape, eval, is infinite, is not a number. We've seen some of these before. There's a ton more. This is just a local sampling of some of the functions that work anywhere in the program. And you'll probably find ones like is not a number, one to test to see is it a character or is it a number. Parse float, parse integer, you probably have seen so far when you've taken strings from input and converted it. So those are also global functions. JavaScript also supports recursion. You can have a function that calls itself. So the process of a recursive call evaluates itself and then sends itself back and calls itself and itself and itself until it actually comes back to nothing, or hopefully there's an ending state. So you can do a recursive evaluation of 5 as an example. In this particular case, it's going to go through 5, and then this is going to be factorial of 5, factorial of 4, factorial of 3, factorial of 2, factorial of 1, and then it's going to return when the factorial is equal to 0 or 1, depending upon how you're going to stop the loop. So, if we were to write this factorial test out, the function actually looks like this. And the reason why we're running it is we're going, well, factorial I, if we look at the factorial I function factorial, we're sending it I, which just happens to be a number, we could just send it 5 as an example. If the number is less than or equal to 1, then return 1. So we're going to test to see if it's 1. Else return number times, look at this, another function call, factorial number minus 1. So we're sending it 5, 4, 3, 2, 1. Oh, it's equal to 1. Okay, we're done. So the same type of recursive function that you would write in C or C++ or Java actually works the same way. So it supports the same construct. So basically the definition of a recursive function is a function that calls itself. So it's not a loop. It's called recursion actually. Here's the factorial of 1 to 10. We sent it 1 through 10 and it recursively gave us the answers out. And it printed it up in a form with a table, or it printed it up, actually probably just a table, not no form, that used the same concept as before by defining the table up front, populating the table full of each one of the table rows, which is not in the code here actually, and then ending the table, closing the table tag. So here's one for Fibonacci numbers, so it's the same thing as before. It's a recursive function for Fibonacci's instead of factorial, where we're going to convert the string to an integer. This one is actually using the parse integer. So we take a string from the input, enter number, or we take it from a form. We parse it to an integer. We display the number in the status bar. And then we display the status bar displays a message to call the Fibonacci number when it's complete. Excuse me, when it's complete, it'll say, hey, status done calculating Fibonacci number. And then there's a test in here, and then there's a call to the Fibonacci. So the function is called Fibonacci. Takes on n, and then we run n minus 1, call Fibonacci again with n minus 1 to do it recursively. So we have what's called a base case, and then we have a recursive case. The base case is, well, what happens for each iteration? Each iteration, we're going to print something to the screen, or we're going to do something, or change a value. And then the recursive call is making it closer to the base case. So it's this number minus something or number plus something if we're decrementing or incrementing to get to our target state that we're looking for. And here is the program output here where we have enter an integer and then calculate, and then on the bottom done calculating. This is the status bar, by the way. So we can document .write to this status bar. It's called the status bar, and then we can put done calculating Fibonacci number. If we were to do that, so the status bar is actually right here. Window.status is equal to done calculating Fibonacci number. And it actually puts done calculating Fibonacci number down here, which is kind of cool. And you can optionally remove the status bar from your browser settings, and if so, the status bar is not going to show for those users who have removed it. So a lot of people have a tendency not to put stuff down there anymore, because browser settings allow you to make it so it's no status bar, no menu bar, nothing. So, and also depending upon the browser, you may or may not see it. So here's more. Enter the number 4. Fibonacci value is 3. So 23 comes out the new Fibonacci number. And here's kind of like how the recursive call works. So we say function 3 and it returns 2. 1, 0 is going to return after the 1 and the 0. So when it hits its base case, when it hits the value that it's looking for to stop, it will come back through and print in recursive order as soon as the function's done. The function actually never returns until the last return occurs, which is the same thing that happens in other programming languages as well. So we're going to save arrays for next time. So someone remind me, because arrays are kind of what's the word for it? They're not tricky, but I see a lot of people fidgeting around. So we'll end with arrays for next time. Do you guys want a review of the assignments? Let's do that. I'm going to end this video, however, because people watching this don't necessarily need the information.